Activity of enzymes. In this lesson, you will learn about the properties of digestive enzymes. Most chemical reactions are slow. To speed the reaction, we can increase the temperature, but it requires a lot of energy. Second, the high temperature can damage all body cells. 3, it speeds up the non-useful reactions. The best way to increase a chemical reaction is with a catalyst. We can define a catalyst as a substance that increases the speed of a reaction without being changed or used. Enzymes are biological catalysts. It means that they are large proteins. Proteins are a chain of amino acids. They are folded to a unique enzymes that catalyzes a particular reaction. It means that each enzyme only breaks down a specific substrate. So the first property is enzymes are specific to substrates. Now let's look at this experiment. In this experiment, we are going to prove how each enzyme works on a specific substrate. We have 3 test tubes. In tube A, we have starch paste plus fresh saliva. In tube B, we have starch milk plus fresh saliva. In tube C, we have chopped egg albumin plus fresh saliva. We place the 3 test tubes in a water bath for 37 degrees Celsius for 1 hour with pH equal to 7. At the end of the experiment, we are going to apply the iodine test, the Fehling solution test, and the coagulation test. We are going to see that iodine test give us a negative result in tube A. It means that we don't have any carbohydrates or starch. And it was positive with the Fehling solution. It means that we have a reducing sugar. In tube B, the iodine water is positive. It means we have carbs. So again, in tube B, the result is positive with the iodine test and negative with the Fehling test. It means that the starch milk is not digested by the fresh saliva or by the salivary amylase into a reducing sugar. In tube C, since we have protein, so we are going to use the coagulation test, and the result is positive. It means that the protein is still present in tube C and is not broken down by the enzyme. So from this experiment, we can see that the variable factor is the substrate. We have 3 different substrates in 3 test tubes with the same enzyme. So we are going to see that the enzyme only breaks starch paste. So each enzyme works on a specific substrate. Now the second property is the temperature. How the temperature affects the activity of enzymes. Let's look at this graph. It shows how the rate of reaction changes with temperature. We can see that as the temperature increases, so is the rate, but after about 37 degrees Celsius, the rate starts to drop rapidly. This is because the high temperature breaks the bonds holding the enzymes together, and so the enzyme is destroyed. So the optimum temperature for enzymatic activity is 37 degrees Celsius, which is the normal body temperature. Now let's look at this experiment about how the temperature affects the activity of enzymes. We have 3 test tubes with the same quantity of starch paste. We are going to add fresh saliva to tubes A and B and a previously boiled saliva at temperature of 60 degrees Celsius in tube C with a pH equal to 7. We are going to place the tube A, or the first tube, at temperature of 0 degrees Celsius, and tubes B and C at temperature of 37 degrees Celsius for 20 minutes. Then we are going to apply the iodine test and the Fehling solution on a small quantity of the content of each tube. We are going to see that iodine water or iodine test is positive in tube A, where the temperature was 0 degrees Celsius, and negative with Fehling solution. It means that the starch is still present.
While in tube B, we are going to see that the iodine test is negative, while the Fehling solution is positive. It means that the starch paste is broken down or digested into a reducing sugar. Now, if we look at tube C, we are going to see that it's still positive with iodine and negative with Fehling, which means that the starch paste is still present and it's not broken down. Now, what is the variable factor in between these three test tubes?
The variable factor in the three test tubes is the temperature. In tube A, the temperature was 0 degrees Celsius. In B, 37 degrees Celsius, which is the normal body temperature. In C, the enzyme was boiled at a very high temperature. So this is the variable factor. We can see that the temperature affects the activity of enzymes at low temperature and at a high temperature. So enzymes at high temperature are destroyed, while at low temperature they are inactive. We are going to see that from the last experiment when we replaced tube A from 0 degrees Celsius to 37 degrees Celsius, how the results changed. With iodine water it was negative, and with the Fehling it's positive, which means that the starch base is broken down into a reducing sugar. Now we are going to talk about the pH, which is the measure of acidity. Now you can see in this graph, if the pH is low or high, it can lower the rate of the reaction. Just like the temperature, this happens because the enzyme bond starts to break. The change in the pH will cause the reaction to become slow until the enzyme is destroyed or inactive. So again, the change in the pH will cause the reaction to become slow until the enzyme is destroyed or inactive. Now the optimum pH depends where the enzyme normally works. For example, the salivary amylase works in a neutral medium where the pH is equal to 7, while pepsin works in acidic medium where the pH is equal to 2 in the stomach. Now let's look at this experiment. This experiment will prove how each enzyme works on a specific pH. We have 3 test tubes. We have the same quantity of starch paste in the 3 test tubes with fresh saliva, with pH equal to 7. We are going to add 3 drops of hydrochloric acid to tube B, and the pH will become 3. And then we are going to add 3 drops of sodium hydroxide to tube C, where the pH becomes 10. We are going to place the 3 test tubes in a water bath of temperature 37 degrees Celsius for 20 minutes. Then we are going to apply the iodine and the Fehling test. We are going to see that only tube A becomes negative with iodine water and positive with Fehling. It means that the starch paste in tube A is broken down or digested into a reducing sugar, while in the other tubes the starch paste remains the same. So now we can know from this experiment that salivary amylase works only in a neutral medium or pH equal to 7, and it becomes inactive or destroyed at the low pH or high pH. Finally, duration. Each enzyme works on a specific duration. Let's look at this experiment to prove how duration affects the activity of enzymes. We have the same substrate in 2 tubes A and B, which is egg, and we are going to add commercial pancreatine in 2 test tubes A and B with pH equal to 8. We are going to place them in temperature of 37 degrees Celsius, tube A for 10 minutes while tube B for 1 hour. At the end, we are going to see that now if we look at the table of results, we are going to see that the Biuret test is only positive with tube A and negative with tube B. It means that the protein is still present in tube A, but it disappeared in tube B. What is the variable factor in this experiment? The duration. From this experiment, we can know that the 10 minutes are not enough for the protein digestion. Now at the end, what are the properties of digestive enzyme? First, specific pH, specific substrate, the normal body temperature 37 degrees Celsius, and a specific duration.